Hi, welcome to our first lesson for 6.3 Pascal's triangle and expanding binomial powers. So it is widely believed that sometime during this 11th century, both the Chinese and Persians discovered this unusual array of numbers. Okay, an array of numbers just basically means like a geometrical set of numbers. Blaise Pascal in the 1600s is credited with the discovery of many of the triangle's special properties and applications, hence it was named after him. So Pascal's triangle, let's talk about that first. It's basically an array of numbers. Okay, Pascal's triangle. Okay, it's just an array of numbers. And there's patterns within this array. Okay, so there's actually many different patterns. Okay, and this array takes on a triangle shape. So the way how the triangle looks is it begins with the number 1. So this is Pascal's triangle, what we're doing right here. It starts with a number 1 on top, and then there's a 1 underneath and another 1 underneath there. So we're kind of getting ready to set up this triangular pattern of numbers, and we're going to have a whole bunch of spots filled in here. So um, we basically have ones along the outside of the triangle, like such. And then the numbers that go in between in here, it depends on the numbers that are directly above. So in order to figure out an entry, so if I want to know what to put in this spot right here, so this number is going to have the value of the two directly above. So this one and this one. When we add those numbers together, we get the entry in the middle, 2. Okay, now to continue filling this out, to get this spot right here, so I'll put that in gray again. We'll get that spot and this spot here. We need to add the numbers that are directly above. So what's directly above here? Well, we have this spot and this spot. We need to add those together. 1 plus 2 gives us 3. Okay. So one way to think about this triangle is if you think of a bunch of like little bowls or cups. Okay, as we pour water into these bowls, it overflows and it lands in the bowls directly above. So, and they'll continue overflowing and land directly in the bowls below. So you can see that this bowl here gets water from this one and this one. So those are the two that you would add together. And this pattern just kind of keeps continuing like such. So if I wanted to figure out this spot here, you can think of it as the bowls pouring in. So we would take the number 1 and add it with the number 2, and we would get 3 in here. Okay, I'm just going to erase these gray spots. So the next line, if you want to try to guess what we would have in here, there's going to be 3 more entries. So this one would be 4 because 1 and 3 add up to 4. This one here is going to be 3 plus 3, so 6. And then 3 and 1 get added to here, that would be 4. Okay, we could continue doing rows like this. We would get 1, and then 1 and 4 make 5, 4 and 6 make 10, 6 and 4 make 10, 4 and 5, 4 and 1 make 5, and then 1 for the last one. So we always have 1s on the outsides, and then the rest are filled with numbers inside. We'll do one more row just to make sure we got the hang of it. We would have 1, 6, 15, 20, 15, 6, and 1. Okay, you might have also noticed there's some symmetry within the triangle. So notice the numbers go from 1 and they go up to 20, and then they go back down to 1 again. So the numbers repeat, and they are symmetrical. So this is called Pascal's triangle, and it continues on for infinity. And there's actually a lot of really cool patterns that can be found within this triangle. And some of them also have useful applications. So one of these special applications, which we'll add right here, is to be able to do binomial expansions. Okay, that's also in the title of the section, so it's kind of a big deal for this section. So what's a binomial expansion? Well, if you remember, binomial just means two terms. So it's basically when we have a polynomial with just two terms, maybe it's a plus b, but then it's raised to a power. So maybe like 3 or 4. And what Pascal's triangle will do is it gives us a shortcut to expand this out. So remember, this is not going to be a to the 4 plus b to the 4. That's not how this works. We would have to do FOIL, right? We'd have 4 sets of brackets, all have a plus b in them. We'd have to do FOIL for each one, and it would take a really long time to finally get an answer, and we'd hope we wouldn't make a mistake along the way. So Pascal's triangle is going to give us a shortcut to solving these. All right, so hopefully we understand what Pascal's triangle is, how to get it, and now we're going to start looking at some of the things that we can do with it. So our first example here, patterns in Pascal's triangle. So part A says, write the first 7 rows of Pascal's triangle and label the rows. So the rows, we'll do Pascal's triangle in red. So row 0 is actually our first number. And then row 1, we have our next 2 entries. So remember, we would just have 1 and 1 here, right? Because 1 adds to 1 here, and the 1 adds to the 1 there. So row 2, we would get 1, 2, 1. Then row 3, we would have 1, 3, 3, 1. And we're going to continue this to row 4, and we would have 1, 4, 6, 4, 1. And row 5, we would have 1, 5, 10, 10, 5, 1. Row 6, we would have 1, 6, 15, 20, 15, 6, and 1. And finally, row 7, we would have 1, 7, 21, 35, 35, 21, 7, and 1. So this makes up the 7 rows of Pascal's triangle. So the row numbers always refer to these entries in here. Okay, so that would be good for part B. Now it says the powers of 2, so the powers of 2, meaning like 2 to the 0, 2 to the 1, 2 squared, powers of 2, they can be found by looking for a pattern in the triangle. Find the patterns. So can you see 2 to the 0, 2 to the 1, 2 squared, 2 cubed inside this triangle? Okay, if you want to pause the video and try to see if you can figure it out, feel free to do so. Okay, so where are these powers of 2? Well, if you take the sum of each row, so row 0, the sum of all the entries is 1. For row 1, the sum is equal to 2, because you do 1 plus 1 to get 2. You guys get the idea. Second row, they add up to 4. And for row 3, the sum is going to be the sum of these numbers. So 1 and 3 is 4, another 3 is 7, another one is 8. You can see the sum is equal to 8. So can you now see the powers of 2? So yes, it is present. And the first row, these can act as our exponents, like the row number. Those are the exponents. And the base is 2. So 2 to the 0 is equal to 1, the sum. So for row 1, 2 to the 1, well, that's equal to 2, which is the sum. So again, that's the pattern. And it's kind of obvious. You can see 2 squared here, and here you see 2 cubed, right? 2 cubed is 8. So the sum of each row, if you add them up, you get the powers of 2. So that's just one of the many patterns that can be found in the triangle. Okay, that's it for our first example, and I'll see you guys in the next video where we look at example 2.